All right, so we're going to look a little bit at solving equations with algebra tiles. We've talked a little about algebra tiles. We looked at, there's like red and blue ones. We've also looked at how to draw them. There's other videos on drawing expressions with those. So we're going to remind ourselves that when we have a filled in square or a filled in tile, that would have a value of +1. If we have a tile that is empty, so it's just an outline, that would have a value of -1. And then we're also going to add, if we have a rectangle, and we'll just do filled in rectangles, that will have a value of x. So that's an unknown value, but if we have an equation or an expression that has an x in it, we will draw one of those algebra tiles. And we're going to kind of follow a method for solving them. And so for that method, the first thing, we have a couple steps. We'll draw a model. We will isolate the variable by adding, subtracting from both sides, and then finally we'll identify the value of the variable. So let's do this with a simple equation that we probably all could answer. X plus 2 equals 5. So you could look at that and probably think, what unknown value for x would make that true? It's going to be 3, but we'll show again how we can do this with algebra tiles and then make more progressively sort of more challenging equations that we can solve. So x plus 2 equals 5. I'm going to draw an x, which again is just the rectangle. I'm going to draw 2 positive squares. I'm going to put my equal sign, and then I'm going to draw 5 positive squares next to it. And now when we have that, we can think x plus 2 on the left-hand side, 5 on the right-hand side. When we have an equation, we want to remember that's balanced. Right now, it's kind of like a balance. And so if we add something to one side, we would have to add it to the other, and it would stay balanced. Or if we take something away from one side and take it away from the other, then it would stay balanced. So we've drawn our model. Step 2, isolate the variable. That means when we want to get it left, so that all we're left with is this x right here. I want to get rid of anything else on the left-hand side of that equation, so I'm just left with that x. So the easiest way to do that is to just take away 2 from the left-hand side. So I could cross off 2 on the left-hand side. And then to keep my equation balanced, I would also cross off 2 on the right-hand side. That leaves me with x on the left-hand side equals on the right-hand side, and 1, 2, 3 positive, so value of +3. Okay, so that's one way that we can do it. I'm going to show you for a lot of these 2 ways to do it. So I'm just going to draw this one more time. And these are going to be a little bit messy, but you'll get the idea. 2, 3, 4, I ran out of room. 5. So the other way is to also think about, we talked about 0 pairs. Now a 0 pair would mean if you have a positive and a negative, that equals 0. They cancel each other out. So if we add 2 negatives to the left-hand side, and we add 2 negatives to the right-hand side, then we can cross out the 0 pairs on the left-hand side, isolating the variable, leaving just x, and we can cross out the 0 pairs on the right-hand side, leaving again x equals 3. So we have an x on the left-hand side and 3 positives on the right-hand side. So we can do, when we solve these, there's always pretty much 2 options. Either taking away the same thing from both sides or adding the opposites to both sides to zero out anything and isolate the variable. All right, we're going to keep going. We're going to do a couple more. So let's say I had x plus 3 equals -1. I'm going to draw it right here with my rectangle. I'm going to draw 3 positives, put my equal sign, and draw 1 -1. I'm going to copy this real quick. All right, so we can kind of show 2 ways to do this. So one of the ways, right, is we can think of, we can look on the left-hand side, we've got an x and 3 positives. On the right-hand side, we've got 1 negative. I can't take away 3 positives from both sides easily, so probably the easiest way would be to add 3 negatives, allowing us to make 0 pairs. And then if we add 3 to the left, we also have to add 3 to the right. I will then cancel out my 0 pairs. I'm left with just the x on the left-hand side. X equals, and on the right-hand side, I see I have 4 empty squares, which means x equals -4. If I did want to take away those positives, the way to do that would be to add 3 0 pairs, and then we could take away 1, 2, 3, 1, 2, 3, and we're left again with x equals -4. Now the top method probably makes a little bit more sense. But again, we can always add negatives to both sides to get rid of any positives. Another example, let's say we had something like x minus 2 equals negative 3. Now for this, you're going to want to think a little bit about subtraction. And subtraction, we can't really draw subtraction, but we can remember that minus 2 is the same thing as plus negative 2. Right, so if you ever see minus, you can just change it and think of it as addition of a negative number. So this I can draw. I can draw my x. I can draw 2 negatives. I can put my equal sign, and I could draw 3 negatives. And then I can go ahead and I can say I want to isolate the variable by leaving just x. So I can get rid of 2 negatives on the left-hand side and 2 negatives on the right-hand side, leaving me with x equals, and on the right-hand side, I've just got negative 1. Alternatively, right, we could do this if we wanted to. We could add 2 positives to the left and 2 positives to the right. That gives us zero pairs, using red. That gives us 0 pairs here, 0 pairs here, giving us, again, x on the left-hand side equals negative 1 on the right-hand side. All right, so this is a way that we can solve these kind of simple addition and subtraction problems. We're going to do a couple more examples. We'll say for something we have like 4 equals x minus 1, because sometimes you'll see that x is on the right-hand side. Don't worry about that. It's no different at all. We're just going to draw our 4 squares on the left-hand side. Where's our equal sign, our x, which is our rectangle, and then it's minus 1, which again, subtraction is the same thing as adding a negative. I want to isolate the variable, so I'm going to look on the right-hand side. I want to get rid of that negative 1. I'm going to do that by adding a positive here, and I can add a positive over here. That allows me to 0 pair out that, and I get 5 equals x. Okay, so we can, again, it doesn't matter which side the x is on, we just draw it, we get rid of the stuff next to the x, and then we get an answer. Okay, we'll keep going. Last 2 problems. For these, let's say you had something like 2x equals 6, because sometimes you'll get more than an x on a side. If that's the case, remember 2x just means you're going to draw 2 x's. So I'll draw my x and another x, put my equal sign, draw 6 positives. They're a little messy, but you get the idea. And to get rid of those, we can't really take away an x from both sides, because we can see we've only got x's on the left side right here. There are no x's on the right-hand side. But what we can do is we can split this in half. So I'm going to split both sides in half, and then I could always get rid of half of something. Right? So half of one side is be equal to the same as half of the other side. And that tells us right here that x is equal to a positive 3. And we know that 2 times 3 equals 6, so that works out. Last problem, we'll kind of make it a little more complicated. Let's say we had 2x minus 1 equals x plus 3. All right, so now we're starting to get a little bit more interesting here. We're going to draw it using the same method. Draw my 2 x's on the left-hand side. Minus 1, remember, is the same thing as plus a negative 1. Equal sign, draw my x. Add 3 positives. I want to isolate the variable and end up with just 1 x on one side. If I look at this, I can see I've got 2 x's on the left and 1 x on the right. So what I can do, I can, just like I could cross off a plus 1 from both sides, I can cross off an x from both sides. That leaves me with, on the left now I've got x and a negative 1, and on the right I've got a positive 3. I want to get rid of that negative 1, so I'm going to add 1 positive to the left-hand side and 1 positive on the right-hand side. That keeps things balanced. The 0 pair can get crossed out, right? And I'm left with just an x on the left-hand side. I've isolated the variable. And on the right-hand side, I've got 1, 2, 3, positive 4. Okay. And we can even check our math to see if 4 actually works by, I can put 4 back into the equation, right? So we had 2 times 4 minus 1 should equal 4 plus 3. Again, I just replaced the x with that positive 4. 2 times 4 gives us 8. 8 minus 1 gives us 7. 4 plus 3 also gives us 7. So we see that x as a solution of 4 does work. So again, for all of these, all you're going to want to do, draw the model, Do the math by adding or subtracting algebra tiles to cancel things out and isolate the variable, and then you've got your answer. Good luck.